Hey guys, this is Mr. C. This is lesson 1 from the first chapter of the book, and this lesson is going to be about rational numbers. It's a pretty straightforward lesson. There aren't too many um, new or crazy things that are happening in in this lesson of the chapter, but it sets the foundation for things that we are going to do. So it's important to make sure you have this background knowledge. So let's just start off with rational numbers. All right, hopefully you have your math notebook. Rational numbers are any numbers that can be written as a fraction. So I put in parentheses right here. The fraction would be some number over another number. The numerator, which I just called a, is any integer. Remember, an integer is a positive or a negative whole number. And b, which I'm having as the denominator, is any non-zero integer. So your denominator can't be 0. And if you have a number that can be written like that, it's a rational number. And if you look at the word rational, just in case no one's ever told you this before, rational, the first part of it is ratio, and as you know, a ratio is a comparison of two numbers that one of the ways you can write it is as a fraction. So that's kind of where rational comes from. So quickly, just some examples of rational numbers: negative 23 or 1/2, 6, 3/4, 28 sixths, a million, whatever. These are all rational numbers, and the reason is you can write them as a fraction, all of them, whether they're already written as a fraction or not. And it follows these stipulations, all right? Of course, you could also have like 6/10. That's a rational number. You can write that as a fraction. 0.23 repeating, okay? Now, one important thing to remember is if you can write it as a fraction, then you can write it as a decimal. For example, I'll take 1/2 because it's a very simple one to work with, and all of us are very familiar. It's a benchmark. Half you can write as a decimal of 5/10 or 0.5, all right? So if you can write it as a fraction, it's a rational number, and that means you can also write it as a decimal. Some of us kind of struggle or forget how to find the decimal expansion of a number, and it's simple. All you're doing is a little division. And this is actually one of those things that I will ask you to at least show me you can do it without a calculator. I will let you use a calculator, but I want to see that you can do it without a calculator. So for the first day or two of this, you need to prove to me that you can do long division, essentially. And if you are not clear or need a little refresher, let's do a quick one. Remember, you're dividing the numerator by the denominator like it says right here. So let's take an easy one. 1/2. The numerator, 1, divided by the denominator, 1 divided by 2. Okay? 2 cannot go into 1, so that means I need to add the decimal point and some zeros. My answer is going to be a decimal, and we already know what 1/2 is as a decimal, but here's the long division to prove it. 2 can go into 10 5 times, 5 times, even I'm a little rusty, and then 10 minus 10 is 0. There's no remainder, so your answer is 0.5 or 5/10. And we're going to work through a little bit of long division in the examples to come. So another important thing to remember is that the decimals that you are writing are either going to be terminating or repeating. I hope that you've heard these words before, and if you haven't, just from basic English vocabulary, you should be able to know what they mean. Terminating are things that stop. They are finite, they end, all right? They don't repeat or go on forever. Terminating decimals stop. So an example could be as simple as the one we just did. 1/2 terminates. It stops. It does not go on. 0.5, 5/10, that's it. A popular problem that we're going to look at in this section of the chapter is batting average, and it's a great time for that. We got playoff baseball going on for those of you who follow sports. And a popular person, at least in this area, is Derek Jeter, so you can at least somewhat relate to it. Batting average is found, it's basically a fraction. So let's look at this example. During a stretch of the season this year, Derek Jeter had 36 hits in 125 at-bats. Find his batting average. So batting average is found, and this is not something you need to know. It's not a formula that I'm going to ask you to remember, but just to give you a little real-life application, he had 36 hits out of 125 chances. All right? So to find his batting average, for those of you who watch baseball, you know that batting average is written as a decimal. And they'll say, for instance, Derek Jeter is batting .310 right now, and it's usually written as .310. The way that they find that is they take the number of hits that they have divided by the number of bats. Anyways, let's do a little long division to find Derek Jeter's batting average. 36 divided by 125. 125 can go into 36 no times. So it's 0. We need a little decimal. All right. 125 can go into 360 twice, and that would be 250. Okay. Do a little subtraction. Okay. 125 can go into 1100. 8 times 125 is 1,000. And if you subtract that, you get 100. Bring down another 0. 125 can go into 1,000. 8 times 125 is, I'm just going to move it over here, sorry, 1,000. So there's no remainder, which means this is a terminating decimal. It does not go on forever. And if we're going to answer the question, Derek Jeter's batting average during that stretch of the season was .288. He was batting .288. But that's the point of the problem, was not batting average. It was to show how to do a little long division and to show what a terminating decimal is. On the flip side, we have repeating decimals. Repeating decimals are not decimals that go on forever, and I'm scrolling too far. Repeating decimals, they do seem to go on forever, but what's going on forever is a repetition of the same digit or group of digits. A popular one that you know as a benchmark is 1/3. That's 0.3. That's 3 repeating. Or even 2/3, you should know, is 6 repeating, 0.6 repeating. So just another example, if you're doing a little bit of long division, you sometimes might come across repeating decimals where it repeats one digit or a group of digits like 0.87, 87, 87, 87, 87, 87. So let's look at this one right now. 27 over 99. Write it as a decimal. Well, to do that, I need to set up some long division. Okay, I know that 99 can go to 27 no times. How many times can 99 go into 270? That would be twice. Okay, and I already worked these out so that I didn't have to sit and do a little guess and check to figure out how many times 99 goes into 270, but you can always, guess and check or do a little mental math. So if we do the subtraction here, we should get 72, and that means I need to bring a 0 down. How many times can 99 go into 720? That would be 7 times, and that would be 693. Okay, if you do the subtraction, you're going to get 27, which means you need to bring down a 0. How many times can 99 go into 270? Well, you should think we've kind of already had that question at the beginning, and it was twice. Okay, and if we subtract, we're going to get 72, bring down a 0, and again you're going to get the same thing. Once you get the same digit or a group of digits repeating twice, I feel like that's enough to justify your answer as a repeating decimal. So you don't have to keep on going and going and going. I see 72, and I already had 270 and 72. So I had the same group of things twice, 2727, that's enough to prove it's repeating. All right, and again, what are we talking about in this chapter? Rational numbers. Rational numbers either repeat or they terminate. They do not go on forever. We're going to talk about those numbers at a different time. Those are irrational numbers, and those are numbers that go on forever. They don't repeat. The most common example of that is pi, 3.141592. It just keeps on going, on and on, no repetition. All right, so all I'm going to do at this point is do 3 example problems from this chapter. If you'd like, you can just pause the video, look at the problem, write it down, and give it a try, and then see if you were right, or you can watch if you just want to see a little more. Essentially, I'm just going to be doing long division. This is another batting average problem. 22 hits out of 80, and the long division would be set up as 22 divided by 80. All right, it goes in 0 times, so I'm going to add my decimal, and I'm just going to work through this one real quick. And again, I already did this one, so if you kind of see me looking to the side, I'm looking at my work, so I don't have to rework the whole problem out. But this is going to go in twice, which is 160. You do the work, you get 60, so I need to bring a 0 down. How many times can 80 go into 60? 7 times. And when you subtract, you'll get 40, bring a 0 down, and 80 can go into 400 5 times evenly, which means there's going to be no remainder, which means at this point, that would be my final answer, and the batting average would be 2.275. And the goal is to show that you can write a fraction as a decimal using long division. Okay, here's one more of those. 55 over 60, write this as a decimal. So instantly you should be thinking, long division, 55 divided by 60. 60 can go into 55 0 times, so I need to add a decimal and a 0. 60 can go into 55 9 times. 9 times 60 is 540. So if you subtract that, you're going to get 10. Bring this down. It can go in 1 time. Let me extend my line. If you do your subtraction, you will get 40. Okay, bring down a 0. 60 can go into 400 6 times, and that's 36. Whoops, excuse me, 360. 6 times 60 is 360, not 36. Okay, and when you do subtraction, you'll get 40 again, so it kind of looks like we might be seeing a pattern, but let's see it twice before we say it's going to be repeating. So 60 can go into 400 6 times, and that's 360, and I'm going to get 40 again, and at this point you can kind of tell yourself, all right, I'm going to keep getting 40, I'm going to keep going in 6 times. So your answer for this, and make sure that you write it properly, it is a repeating decimal, but the only digit that repeats is the 6. So the macron needs to go over only the 6, not the 9 and the 1. The 6 is the only digit that repeats, and that would be your final answer. And my last one that I'm going to look at says write 1 and 345 thousandths as a mixed number in simplest form. Now, if you caught how I pronounced that number, instead of saying 1.345, if you can say your numbers correctly, these problems will be the easiest thing in the world for you, because how I said it, 345 thousandths. Why did I say that? The furthest digit is the 5, and what place is it in? It's in the thousandths place. All right, if you can identify that last place value, that tells you what your fraction is going to be. And what I mean is, okay, I'm going to say the word again, the number again, and I'm going to write it down as I say it. 1 and 345 thousandths. 1 and 345 thousandths. So what I did, and this is the first step because it says to put it in simplest form, is I took the number, I found the last place value, the biggest place value, or I guess smallest, and that tells me what my denominator is going to be. And how did I know that the 1 is a whole number here? Because it's not a decimal, it's a whole number. 1 whole and 345 thousandths, that's the part. So to simplify this, I need to just start dividing down. Don't be a hero if you're not really sure how to do it in one step, do it in smaller steps. I know that 345 and 1,000 both can be divided by 5. Okay? They're both numbers that can be divided by 5. Hopefully you remember your divisibility rules. That will help you with determining that, but start small. So 345 divided by 5. 345, and I'm going to speed this up so you can just get an answer, is 69, and 1,000 divided by 5 obviously is 200. All right, that's mental math. So again, write it as a mixed number in the simplest form. 1 and 69 over 200. I know that there is no other number that can go into both the numerator, 69, and the denominator, 200, which means I can't simplify it anymore. So it's in simplest form, and again, that whole number just stays put, and that's your final answer. So that's basically what this section of the chapter is about. It's going to be a little tedious. It's going to take a little bit of practice just to get proficient at it, but as long as you're proficient with this, it sets a great base for the rest of the chapter. So here are your summary questions. I'm going to fill in the numbers right now for those first two. So for the first one, I want you to write 138 over 150 as a decimal. And for the second one, I want you to write 12 over 11 as a decimal. Do not use a calculator, as tempted as you might be. Maybe if you want to check yourself, you can use a calculator, but I'd like to see the long division for both of those problems. For the third one, I want you to write 3, and I'm not going to read it properly because I just want to see what you can do on your own. 3.225, which never read it like that. I'm just doing that so I don't give it away. Write that as a mixed number in simplest form, and we'll call it a day with those 3. All right, give them a try. If you're not sure of something specific, give me a specific question in your notebook or questions so that I can answer them. Otherwise, do your best, and we'll go over all of this tomorrow in class, and I will see you then. Have a wonderful rest of your evening.